All right, this is section 3.2, the derivative as a function. So the definition says the derivative of f of x with respect to x is a function given that f prime at x equals the limit as h approaches 0 of f at x plus h minus f at x over h. The domain of f prime of x, which means the derivative, by the way, is x such that x is in the domain of f such that the derivative at x exists. So f prime of x, or the derivative, represents either 1, the slope of a tangent line to f of x at x, or 2, the instantaneous rate of change of f of x with respect to x at x. So all of test 2 is covering derivatives. So it's very important to know what a derivative is. So once again, what is it? It's a tangent line at some point x, whatever x is. Or, if we're talking about word problems, it's the instantaneous rate of change. So what is that change at that particular point in time, for instance? So we're going to look at example 1a together. And we're going to use the graph of y equals f of x to estimate the value of each derivative function. Then, sketch the graph of f prime of x. Okay, so if I look at this, my main function, and I'm going to go ahead and put that in red, is this parabola, right? And the lines that are tangent to that, and let me grab the blue here, are here and here. So these are the tangent lines at these 2 points that I just really highlighted, okay? So use the graph of y equals f of x to estimate the value of each of the derivative functions, and sketch the graph of f prime of x. So what is the derivative at 0? So if we look at 0, which is right here, there is no rate of change because it's a flat line. That's the tangent line at 0. So the answer to this is 0. Okay? So once again, when we say what's the derivative, that is the slope of the tangent line, just so you're familiar with what I'm talking about. So now I'm going to look at the derivative at the value of 1. So I'm going to erase all this stuff off so we can see it a little bit clearly. So here is where x equals 1, and this is the tangent line. So I want to find what the slope is. So what's the slope at that point? Well, I know that this point is, 1, 1 here. And I got to figure out another point. So I know that my line crosses the y-axis at 0, -1. Now you have a choice here. You can either use the slope formula, which is y2 minus y1 over x2 minus x1. That's one option. Or you could use rise over run. So if you choose to use rise over run, we're going to go 1, 2 places up and 1 over to the right. So what's the slope? The slope is 2 over 1, which is 2. So that is the slope at the tangent line at the value of 1. Okay? So let's go ahead, and I'm going to erase this stuff. I'm going to leave the slope formula up there just if you want to use it. And now we're going to look at what is the derivative when x equals -2. So I'm looking at this line here because that's the tangent line when x equals -2. And I'm going to find out what the slope is. So once again, I'm going to kind of look at where it crosses the x-axis here. So I have these 2 points. I have, -2, 4, and then I have this point, which is -1, 0. Okay? So you can once again do rise over run. So if you do rise over run, I went up 1, 2, 3, 4 units and 1 to the left there. So I get 4 over -1 or -4. Okay? So I'm going to go ahead and put that in there. And once again, if you want to use y2 minus y1 over x2 minus x1, you can. I'm just using rise over run to figure out the information. Okay, so let's look at f prime, or the derivative, at -1. Okay, so let me go ahead and erase this stuff so I don't want to confuse you. Okay, so -1, when x equals -1, is this point right here. And because we have symmetry, we can conclude that the line is going to be the same when the derivative equals 1. So I know that the slope when the derivative is at x equals 1 is positive, right? And we concluded that it was a 2. That's the slope at when x equals 1. And since it's symmetrical to this line here, the slope is just opposite. So the slope's going to be -2. And we can do the same thing when f prime is at x equals 2. So once again, I'm looking at this point here. It's symmetrical to this point here. So we found out that the slope at -2 was -4. So I just have to use the same slope. So it's going to be 4. And the opposite sign, so it's +4. Okay? So we can use symmetry because this was a parabola with a vertex at 0, 0. All right. So next bit, what is the domain of f of x? Remember, domain is all possible x values, right? So if we look at this, we can see this function, is heading off into -infinity, and if you go, left to right, we see that this is going to, excuse me, I said -infinity. This is going to positive infinity, and then positive infinity over here, right? So if I look at that, all possible x values, it keeps on going on and on, getting more and more negative. So I have -infinity to positive infinity. So what's the domain? -infinity to positive infinity. Okay? All right. So let me go ahead and erase that, and we can look at the domain of the derivative. So if we go along and we make points and we check out, the lines, they're going to continuously change, right? So they're not going to stay the same. I mean, for instance, right up here, it's going to be a line like that, right? So as we go along these points, the tangent line is changing. But remember that it's a line. So if you remember the lines, if I look at, just one of these lines, one that's already drawn for us, we can see if we get more and more negative, the x's are getting more and more negative, and then it goes all the way when x is getting more and more positive. So remember, domain is all possible x values. So my x values can be -infinity to positive infinity because it's a line. Okay? All right, so let's look at example 1b. Example 1b says, given f at x equals x squared, use the definition to find the equation of f prime at x. All right, so the definition says f prime of x, or the derivative at x, equals the limit as h is approaching 0 of the function of x plus h minus the function at x all over h. So what we have to do is we got to plug this in, and we got to figure out what the value is, okay? So remember, my function is x squared, right? So it says a function at x plus h. So what I'm doing is I'm going to plug in x plus h for x, and then I'm going to square it. So I get x plus h squared. Why? Because once again, I'm plugging in x plus h in for x. Minus, now it says to plug the function, just plug in x. So I'm going to plug x into x squared, and I get the same thing, x squared. And then it's over h. Okay? So if I expand that out, I get x squared plus 2xh plus h squared. And if you don't know how I got that, I have two binomials, and then I, distribute them or FOIL them out, right? And this is minus x squared over h, okay? At this point, the x squareds are going to go away, so I'm left with 2xh plus h squared all over h. Now I can factor out an h. So if I factor out an h, I have 2x plus h all over h. And now I can reduce that down, and I have the limit as h is approaching 0 of 2x plus h. So now all I have to do is plug and chug. So it says h is approaching 0. So I have 2x, and wherever I see h, I'm plugging in 0, so I'm left with just 2x. So what is the derivative of x squared? That is the slope, by the way. So your slope is 2x, okay? So now I can plug in whatever I want, whatever point I want on that function, and I'll find out what the derivative is. All right, let's look at example 2 together. Same thing. If f of x equals the square root of x minus 1, use the definition to find the equation for f prime of x. Okay. So once again, the definition says limit as h is approaching 0 of the function of x plus h minus the function at x all over h. Okay. So once again, wherever I see x, I'm going to plug in x plus h. So this becomes the square root of x plus h minus 1 minus, now I'm going to just plug in just x for x. So I get square root of x minus 1 all over h. Now this thing is a little bit complicated, so what I'm going to do is use a conjugate to try to simplify this a little bit. So the conjugate of the square root of x plus h minus 1 minus square root of x minus 1 is the square root of x plus h minus 1 plus the square root of x minus 1. Now, if you notice, I got the difference of perfect squares, right? So if you FOIL this out, because it's a binomial, right, you'll see that your middle terms cancel, and you square your first term, square your last. So if I square my first term minus I square my last term, and by the way, I can only do this because of, the opposite signs here. And in the bottom, by the way, I can't leave that just alone. I have to put the same thing because it's like multiplying by 1. I get h times the square root of x plus h minus 1 plus the square root of x minus 1. Okay? All right, so let's see what this looks like. So if I square this, squaring a square root basically eliminates the square root. So I get x plus h minus 1 minus, and once again, squaring a square root, I get x minus 1 all over h times the square root of x plus h minus 1 plus square root of x minus 1. Okay. All right. So simplifying this again, I get x plus h minus 1 minus x plus 1. So what happens here is the x's cancel each other and the 1's cancel each other. So what am I left with? In the numerator, I'm left with h. Now I have h over h times the square root of x plus h minus 1 plus the square root of x plus 1. Excuse me, x minus 1. I gotta be careful there. And the h's now cancel. Okay, so now I'm ready to take the limit. So I'm taking the limit as h approaches 0 of 1 over the square root of x plus h minus 1 plus the square root of x minus 1. Okay? So once again, plug and play. Wherever I see h, I'm plugging in 0. So I get 1 over square root of x minus 1 plus square root of x minus 1. To simplify that, I'm going to get 1 over 2 square root of x minus 1. And that is your slope. Okay, that's your derivative at any point. Okay? So part B says find the equation of the tangent line when x equals 5. Okay? Now I know my slopes formula is 1 over 2 radical x minus 1. So I plug in, wherever I see x, I'm going to plug in 5. So I have 1 over 2 times the square root of 5 minus 1. So 1 over 2 radical 4. And this is going to be 1 over 2 times 2, which equals 1 over 4. So the slope when x equals 5 is 1/4. What's the domain? So because, the regular equation was f of x equals the square root of x minus 1, we have ourselves a square root. Remember, you can't have a negative under a square root because it causes it to be imaginary. So the question is, where does it start and what numbers go in here? Well, if you zero out or set whatever's underneath the square root equal to 0, you get x equals 1. When I plug in 1, I get the square root of 0, which is 0. So that's your starting point. So I'm going to start at 1, and then I can plug in any number bigger than 1, and it'll make it a positive underneath the radical. For instance, if I plug in 2, I get 2 minus 1, which is 1. That's okay. If I plug in 500, I get 500 minus 1, which is 499. Square root of 499 gives me a positive value. So I start at 1, and I go to positive infinity. Okay? What is the domain of f prime of x? Well, our formula was 1 over 2 radical x minus 1. So once again, we have the same problem where we have a square root. So we have to find the starting place. So x minus 1 equals 0, x equals 1. So that will zero out the denominator, right? And if I zero out the denominator, I get 1 over 0. I get 1 over 2 times 0, which is 1 over 0. Remember, that's undefined. So I cannot include 1 in my solution because it's in the denominator, but I can include every number bigger than that because that'll make it a positive value. So your domain is 1 to positive infinity. In part D, use a graphing calculator. We're actually going to skip this, but you can do it. You can download Desmos onto your phone. It's free. And what you can do is you can, put y equals square root of x minus 1, graph that. That's the original function. And then graph the tangent or the equation, y equals 1, and then you're going to do divided by parentheses 2 times the square root of x minus 1. And you'll see both equations so you can see what's going on with them, okay? Basically, when you graph this 1 divided by 2 times the square root of x minus 1, you're going to see that the larger x gets, you're going to see that the whole function kind of flattens out. The slopes become less and less severe. Okay? All right, so that's it for this video. That's part 1. We're going to do part 2 and probably part 3 of this section as well.